Hello and welcome to Critical Thinking Lecture 12. Today I'm going to work through a summary of descriptions and challenges, also strategies, and then we're going to supplement with some statistics. We'll start here. These are some of the descriptions of your cognitive systems that we've talked about before, and over on the right we have challenges to be addressed. Now I'll walk through this. I've done it before, but it's always good to refresh. Remember, System 1 and System 2, that's that slow and fast thinking. Sometimes we're methodical, sometimes we run with our gut. Now, this is, again, faster and slower sometimes. On the other hand, we have emotions and rationality, sometimes thinking very carefully, and we're using reason to figure out the ways the world should be or the ways the world is, and other times we're motivated by emotional pull and affect. Valence, as I mentioned, is needed to run the calculation. If you don't have the feelings, you're not going to know how to care. Model of cognition. Remember, we have inputs that come in from our stimuli from our environments using like our eyes and our ears. Now this is encoded into hierarchies, concepts, and webs of belief that are underwritten by it. We also use these webs of belief and webs of desires to behave and act and do things in the world. I want that water. I believe it is water. I know what water is, and I know it's the sort of thing that will quench my thirst because I've seen this before in the past, so I shall drink it. On the other hand, we use syntax and semantics. These are aspects of our language. We use syntax as a way to sort of lump things together, lump terms together, like names and verbs and whatnot, and also to pick things out in the world, like that dog. And semantics are the things that we pick out, and the syntax being the sort of shorthand for those things. 3 types of reasoning. Remember, we had direct, indirect, and conditional, except we also added another. So we'll say 4 types of reasoning because we also have inductive reasoning. This is where you have like a sample and you infer to the general case or to the population based on a relatively limited sample. Now we also have pattern recognition. This is an aspect of our psychology. We see fire is hot, and it better be, right? Like that better be what you take away from it if you get burned. Don't touch it again. We develop patterns, and often this is a useful thing for our survival. Now, on the other hand, we have challenges, like our attention. It's limited. We can only attend to so many things. Our memory, in short and long and episodic, we can only remember a certain number of things. Sometimes we get mixed up with what we do remember. Our emotions get involved. Our stress gets involved. And that can make us either not remember as much or misremember things. We go, stress right there undermines attention and encoding. As I mentioned, now we have limited foresight. It's hard for us to think about the future. It's even harder for us to delay gratification. Recall, we have a hard time saving money for the future, and there seems to be some sort of biological or biophysical or biosociological underpinnings of that. We also have cognitive biases. We talked about anchor bias and availability bias and priming, how susceptible we are to priming, that is. Also, today we're going to be talking about sunk cost bias, base rate bias, and post hoc bias. So we'll be supplementing, again, as I mentioned with statistics, some of the challenges here. And before we leave here, we've got challenges like pattern recognizers. So sometimes our pattern recognition systems go too far. We over-represent. Sometimes, for instance, we may take a sample and make an inductive argument to a population that over-represents for various reasons. We might make, for instance, a hasty generalization based on a pattern that we want to be true. Now, let me summarize some strategies. Meditation. Pause, relax, get your emotions in your head in order before you handle a stressful problem. Leaves on the stream, or love yourself, or thinking about that room that we're building, one where you're going to place things to remember. Train with the end back to help you focus on your attention. I want to add here mental rotation, that mental rotation challenge that I gave you. I gave you a little link, had you rotate things in your mind. This is good to help you expand your imagining capabilities. Now over here on the active side, we have representational translations. Remember, that was algebra and geometry. We're going to be using that more and more as we go on. Don't worry, we're not doing math. We're just using some of the benefits that you can gain without doing math from representational translations. We also have visualization as an active thing you can do. Creatively imagining things. The more you do it like a muscle, the better you are at it. We chunk. Remember, grouping things together so we can remember more. We also sometimes divide things up so we can handle them, so we're not overwhelmed. Like puzzles that seem overwhelming, we can divide them into parts and solve the parts and then build the whole. Break it down. Also, we want to add in here boundary checking. Remember the flagpole example? This helps us because if we can look at the extremes of a given problem and we know what the boundaries are, we can constrain options and maybe limit that initially insurmountable seeming issue or problem to a smaller sort of thing that can be dealt with. Now, we also have the squares of opposition. We have all sum from the original one. We also have the modal square and the probabilistic square. And this is a useful way to encode a lot of information with a heuristic that you can carry with you wherever you are. We also have arguments, validity and soundness, right? And these help you figure out what follows from what and where you want to focus your attention if you don't think an argument is good. Arguments are everywhere. We see them all over the place. They're not always good. We also have properties and relations. These are active things to look out for. Now, things that can, again, encode a lot of information just based on minimal knowledge that you have. Now, I'm going to move over here to supplementing all of this with statistics. Particularly, we're going to be talking about mean, median, mode, causation and correlation, etc. We'll start here. Consider the 1985 graduating class of UNC. Which graduates do you think had the highest average starting salary? I'll let you think about it. Whatever your guess, I bet it wasn't cultural geography. Michael Jordan, it turned out, graduated that year with a degree in cultural geography and a starting salary of $700,000 per year. That means, if you crunch the numbers, the average starting salary, again, for cultural geography that year, $250,000 a year. Wow. Check this out. Average versus median. If you're thinking just about averages, then you might have skewed information. Now, outliers like Michael Jordan will skew the average. It's not true that most of them made $250,000 a year, right? It's just that it seems like that if you're thinking about the average because Michael Jordan made so much more than everybody else. If you think about this, right, the average and median incomes, just thinking about the average, we have a lot of wealth inequality in the U.S. Outliers will skew this. But if we look at just another aspect of the data, median, that's just the middle case, then we'll see that these numbers are quite a bit different. Bezos and Gates, for instance, are the skewing this. Now, the median, though, corrects for these outliers. The median is 50% above and 50% below that line. They're useful for calculating ratios, these means and medians, but they're not so helpful for determining tendencies based on simple counting. For example, the top names for babies in a given year. You look at this, these aren't really like, you're just like counting the names, right? It's not really an average. It's on or off, right? It's also not a mean. What you have here are nominal variables. And the mode, which is another aspect of the data that's useful for us to know, is the item in a group that appears most frequently. Leonardo over here. Most common names among male babies in Italy in 2018. The mean of a sample, just summing this all up, is the sum of all the values of the sample divided by the number of values. Suppose you have $20. Your mom has 200 and your dad has 80. Together you have 300, but on average you each have 100. The median of a sample is the number in the middle of the sample once it's been ordered. The median of 20, 80, and 200 is 80, since it's in the middle. Now the mode is the item that appears most frequently in the list. In our example, each of the cash amounts being the mode because they each appear just as frequently as the others. Here, just for fun, how many popes are there at any given time? I know what you think, but it really depends on how you're counting. The Vatican is 0.17 square miles, so there are approximately 6 popes per square mile. Okay, moving over. Causation and correlation. Here's a surprising fact that mainstream media doesn't want you to know. There's a strong correlation between rising global average temperature and the decrease in the number of pirates occupying global waters. Check it out. Here we go. These are Jolly Rogers representing the existence of prevalence of pirates at a given time. As you can see, as time moves on and the climate rises or the temperature rises, you have fewer and fewer pirates. Causation. This is just to illustrate, is not correlation because this relationship is not not one-to-one, or not very important, right? It's sort of accidental that this happened. It's not like having fewer pirates causes global warming. Correlations are just everywhere. Causation is quite a bit rarer. If you're interested in finding out more of these correlations, check this out. You can go to this website here. I'm illustrating the number of people who drowned by falling into a pool and how that correlates with films that Nicolas Cage has appeared in. Now, all right, perhaps more interesting than the preceding, let's talk about the base rate reasoning fallacy. Suppose you've just been tested for COVID-19 and it's positive. The test, we'll say, has a 95% accuracy. That is, 95% of those infected are classified as positive and 95% not infected have a negative result. We'll say the prevalence of infection in the population is 1 in 125. What's the probability that you've been infected? I bet you're surprised. Only 13%, even though you have a positive test. Suspect you thought it would be quite higher. Well, humans seem to be disposed to make this sort of base rate fallacy. That is to say, we make a statistical inference based that ignores the expected prior probability, or in this case, the disease prevalence in a region. We tend to conflate, this is to say, the proportion of actual positive cases classified as positive and the proportion of cases classified as positive that are actually positive. But if our test is very accurate, like 95%, while the disease prevalence is low, 1 in 125, we may have a large number of false positives. Let's see how this works. So this is the U.S. population, 328 million. Infection prevalence, we were saying, is 1 in 125. Now, this is to say that there are about 2,624,000 infected people and 325,376,000 not infected by that reason. Now, if the test is 95% accurate, that is to say that 2,492,800 would test positive out of the infected group, and 131,200 would test negative. So we have true positives and false negatives, okay? Because those 131,200 should have been positive. But that's the 95% rate, right? If we go over here, we also have a 95% accuracy for those not infected, which is to say we have 309,107,200 that test negative if given this 95% accuracy test, and 16,268,800 that test positive. That is true negatives and false positives. And false positives, as you can see here, quite a lot. If we add these together, we have 18,761,600 total positives using this test, with only 2,492,800 actual positives. So if we divide the real positives by the total positives, it's 13%. So what is the probability that you've been given a positive or a COVID test and it tests positive and you actually have the disease? 13%. The proportion here, just to see the numbers of actual positive cases classified as positive being 13%. But again, we shouldn't conflate that with the proportion of cases classified as positive that are actually positive, which is 95%. Now, I'll talk to you a bit about the prisoner's dilemma. Suppose two siblings, A and B, would have been involved in a spray painting a wall, Banksy style, but their mother suspects they're culprits and is trying to figure out what happened. Who did what exactly? She separates A and B and lays out the following dilemma for each. If A and B betray each other, then they'll both be grounded for 2 months. But if A betrays B while B remains silent, then A will not be grounded, but B will be grounded for 3 months, and similarly for B. But if both remain silent, they'll both be grounded for only a month. Let's see what their options are. A stays silent or A betrays. B stays silent, B betrays. If they both stay silent, they just get a month. If they both betray, they get 2 months. If one stays silent and the other one betrays, well, you see, 0 and 3, or 3 and 0. This is obviously the better move, right? This is the prisoner's dilemma. When you're stuck in a dilemma like this, the wise thing to do, the rational thing to do, they say, is to not talk. Of course, that assumes that the other person will as well. And we're going to talk more about this in class. It's that trust aspect that makes this a dilemma. Of course, that said, you should do this. But this is not an ideal or not a rational move, right? Because you don't really know what B is going to do. And this is, of course, the worst move. Because if you both betray, and this is the risk you take if one of you talks. If you both betray, you're both worse off. Now, check this out. I'm going to use some of this thinking to talk about God. Blaise Pascal. He thought he might have an argument to convince people to rethink whether or not God exists if they're not so inclined. You could believe or not, right? And God exists or God doesn't. This is the sort of table he was thinking about. And he's bringing this to, say, an atheist and saying, hey, check it out. This is the setup, right? You either believe or you don't. Either God exists or God doesn't. Now, let's talk it through. If God exists and you're a believer, you get infinite gain. You go to heaven. Yay. Now, if God exists and you don't believe, hell, like that's an infinite loss. Now, what do you lose for believing if God doesn't exist? All right, so what? You got to go to church. You don't get to watch the game. Okay, that's whatever the case. It's a finite loss. And what do you get if you don't believe? You get to go watch the game, right? You drink, you smoke, you cuss. That's a finite gain. In any event, either way, infinite, that overrides or swamps finite. An infinite gain is greater than a finite loss, and an infinite loss is much less than a finite gain. So in either way, you ought to assume, or you ought to just believe, right? Of course, there are several problems with using this as an argument for a belief in God, and we'll talk about it in a bit. But hopefully you get the general idea. Now, lastly, we'll talk about the wisdom of the crowds. This is a heuristic, a strategy we'll use to supplement the other ones we have. In 1906, 800 people participated in a contest to estimate the weight of an ox. And Francis Galton was there, and he observed that the median guess, 1,207 pounds, was within 1% of the actual weight of the ox. And he argued this was because people who had a reasonable idea of the actual weight would guess near the median, and those who didn't would cancel each other out. They'd be outliers, but they'd be either too high or too low. This is the wisdom of the crowd's heuristic. I use this heuristic when I'm exploring Reddit for what it's worth. I don't want to think about the most comfortable shoes to buy, so instead I navigate to Reddit and I check out the answers to the question, what shoes should I buy? And the top commenters are the ones who typically know what they're talking about, and then you got a bunch of junk posts, but they all cancel each other out. People don't upvote them. Or somebody will say this, and somebody will contradict them, and neither knows what they're talking about. Again, cream rises to the top, and I've got some pretty swanky, comfortable shoes. Now, this is a new strategy to keep in mind. We'll supplement it with the others, and we'll use it a couple of times in class for practice.